This is a short lesson on a topic that we're going to then take and use to help us work with polynomials. So it's called the distributive law, and it's, as it says, it's about multiplication. It's strictly about multiplication, no addition, subtraction, division. All it is sort of a way of thinking about multiplication. It tells us how to distribute, in other words, sort of spread around a number that is outside of a bracket and expand it so that we're multiplying each term inside a bracket by that same number. So that's why it's sometimes called expanding, right? We take whatever's in front of the brackets, we multiply with each term inside the brackets, and we also have to remember our exponent rules. That's very important. So I'm going to underline that in red. We have to remember our exponent rules when we're doing this distributive law, when we're multiplying numbers with the same base. So let's just look at, we got, 7 examples? And that should be enough for you to get the idea. So whatever is in front of a bracket, we multiply it by what's inside the bracket. And so I multiply the numbers times the numbers and the letters times the letters. So I'm going to multiply this 3 times this 5, in other words. 3 times 5, as you know, is 15. And I've still got this x here. So if you think about it logically, if I've got 5x inside the brackets and I multiply that by 3, that's 5x. Same as doing 5x plus 5x plus 5x. Now I've got 15x's, right? It's the same idea. If I multiply 2 times 3, then I get 6. However, this one's a bit different because I've got an x inside the brackets and an x outside the brackets. So I'm going to multiply those x's together as well. X times x, we know, can be written as an exponent, as x squared. Another way we could think about multiplying this x times x is, remember, we're assumed to have a 1 exponent whenever we don't have an exponent written. So we can assume a 1 on these x's. And so if we imagine we're multiplying x to the 1 times x to the 1, using our multiplying powers rule, that would be the same as x to the 1 plus 1, and we would get x to the 2. So that's another way of thinking about it that's actually going to come in handy later. Now in the next one, we've got 4 times 5, and we know that's 20. And then we've got an x, and we've got a y, but they're not the same. So I certainly can't use the multiplying powers rule on them since they don't have the same base. And even just thinking about multiplying them together, like x times x equaling x squared, doesn't work when I do x times y. If I can't do anything with them, I just have to write them down again. So I'd have 20, which I already got, and I'd just have xy. So I just write them. That means 20 times x times y. If I write things beside each other like this, it means we're multiplying them together. So I guess that's all I've got to say for that one. All right, let's move on to, as you can see, they're getting longer and more complicated looking. The next one, I'm multiplying 3 and a 10 together. Those are the coefficients. That gives me 30. I've got an x and an x squared. Now, these aren't like terms, so this is, again, where it's a little different, and you have to be careful, but it's not like terms we're looking for here. We're just looking for the same base. So we're using this powers rule. So I'm going to multiply 2 powers with the same base. One of them's x to the 1, and the other one's x to the 2. And so then we have x to the 1 plus 2, which is x to the 3. So I'd write that down. And I've also got y's, right? So I've got this y, which is assumed to be y to the 1, and y to the 3 here. And when I multiply them together, I add those exponents, and I get y to the 4. And again, so we multiply together the things we can, numbers times numbers, x's times x's, y's times y's, do what we have to do to the exponents. And again, this means 30 times x cubed times y to the 4, but it's a single term. Now in this next row, we're going to look at ones that involve more than one term. So in questions 1 to 4, we were multiplying what was called a monomial. If you remember, a monomial is a single term. So we were multiplying a monomial outside the brackets times a monomial inside the brackets, monomial times a monomial. Now we're going to multiply a monomial outside the brackets times a binomial or even a trinomial. In number 5, we're multiplying 5, which is a monomial, times 4a plus 7, which is a binomial. And things start to get a little bit, they're not tricky, you just have to know what's going on. I'm going to literally multiply 5, it's still the number times the number, but I'm going to multiply it times each of the numbers inside the brackets. And this is where remember it's called the distributive law? This is where the distribution part comes in. I'm going to distribute that 5 over each of the terms. And so 5 times 4 is 20. And 5 times 7 is 35. I'll just write those two parts down for starters. Of course, there was more to the 4a. There was an a beside that 4, so there's still going to be an a beside the 20. And the 7 was a constant term. So if I multiply a monomial times a binomial, I'm going to get a binomial for an answer. It's just going to be a bigger binomial. Now I'm going to multiply 2k times the first term and 2k times the second term. So I'm basically going to do the same thing twice. I'm going to multiply 2 times 5 and get 10. And then I'm going to do k times m. If I ignore the 3k to the 4 in the end right now, just focus on the 5m. Well, again, we got a situation where k and m are not like terms. They're not common base exponents that are powers that I can multiply together. I just have to write 10km for the first one. And then for the next one, I'm going to do that 2 times -3, and I get -6. And I'm going to multiply this k. It is got a power with the same base as k to the 4, again, assuming there's a 1 there. I'm going to do k to the 4 plus 1, which is k to the 5. So I got the 10 and the -6 from multiplying it times the 2. I got the k to the 5 from multiplying the k's together. And I got the km just because that was all that was left when I couldn't combine those anymore. The last example just shows that we can do the same thing to a trinomial. So we're doing a monomial times a trinomial, and it's got a lot of parts, but we just match them up like we've been doing. So we're just taking what we've been doing and extending it a little farther. We're going to do 4 times 2, first of all, and that gives us 8. We're going to do x times x. And again, that's x to the 1 times x to the 1. So we add those exponents together, and we get x to the 2. Then we're going to multiply, well, actually, we're not going to multiply anything else. We got this y at the end of that term there, which got nothing to multiply it by, so I write it down. That was my first set of multiplications. Now I'm going to distribute this 4x to the next part, and I'm going to multiply the 4 times -7, and I get -28. And I can't combine the x and the y squared. They're not powers with the same base again, so I can write the x down, and I can write the y squared down, but there's nothing to change on them. I just write them down side by side, and so then I'm done that one. Then I go to the next one, and I'm going to multiply 4 times 5, and I get 20. And I'm going to multiply x times x cubed. And again, I'm going to add the exponents, so I'm going to get x to the 4. And there I'm done. Just a word about this. Take a look. This will go for any of them, but take a look at these 3 terms, 1, 2, 3 terms. One of them is an x squared times y. I have to look at this whole thing. This is one big term. If I want to combine any terms, I need to have another x squared y term, which is not what this one is. This is an xy squared term. They both have x's and y's in them, and they even both have a squared in them. But the squared's on the x in the first one and on the y on the other. So they're not like terms. I can't combine that 8x squared y with the 28xy squared. They're not the same. And obviously they're the same or different from this last term, which is just an x to the 4 term. So in order to have like terms, they have to be exactly the same variables, either one variable or a combination of variables, like we had in the first two here. but they also have to have the exact same exponents on them, which we didn't have in the first term. So I can't combine these anymore. Sometimes people try to combine these more than they can, but you have to know when to stop. For every one of these, I stopped at the right place. If I tried to go further, then I would be doing something mathematically wrong. Okay? Give that a try.